This lecture video covers content from your Chapter 6, Section 5 lecture note. We'll be talking about a general strategy for factoring polynomials. When we're factoring polynomials, we need to run through a mental checklist. First, we're going to look for any common factors that need to be factored out. Then we'll consider the number of terms in the polynomial. If there's 2, we'll check to see if it's one of the special binomials. If there's 3 terms, then we might try factoring by grouping or by trial and error. And if there's 4 terms, we'll try to factor by grouping. After we've done an initial round of factoring, it's important to check to see if any of the factors can be factored further. Looking at this first example, we notice right away that there is a common factor of 3. I prefer to factor out -3 so that we're left with a positive x squared instead of a negative x squared. Factoring out this -3 leaves us with positive x squared minus 2x minus 35. Now we have a trinomial with a leading coefficient of 1. Let's try to factor it into 2 binomials. Since we have a simple x squared as our leading term, we know that these binomials will look like x plus or minus a constant times x plus or minus another constant. Our 2 constants need to multiply to -35 and add to -2. Those will be -7 and +5. -7 times 5 is -35. -7 plus 5 is -2. Now we've factored this polynomial completely. Now let's look at another example. Here we have 125a cubed minus 27b to the 6th times c to the 9th. A quick check for common factors tells us that the greatest common factor is simply 1. This is a binomial, so we'll check and see if it's one of our special binomials. That's a difference of squares or the sum or difference of cubes. A little manipulation helps us see that this is the difference of 2 cubes. 125 is 5 cubed, so the first term can be written as 5a cubed. 27 is 3 cubed, so the second term could be written as 3 times b squared times c cubed, all cubed. Now we can factor this as the difference of cubes. Now that we can clearly see this as a difference of cubes, we know this factors as 5a minus 3b squared c cubed times 5a squared plus 5a times 3b squared c cubed plus 3b squared c cubed squared. Cleaning this up a little, we have 5a minus 3b squared c cubed times 5a squared, or 25a squared, plus 5a times 3b squared c cubed. That's 15a b squared c cubed, plus 3b squared c cubed squared, which is 9 times b to the 4th times c to the 6th. And we've successfully factored this binomial. Now we'll take a look at example 3. First, let's check for any common factors. The greatest common factor is simply 1. So we move on to looking at the number of terms. With 4 terms, we consider factoring by grouping. Looking at our first 2 terms, we can factor out an x squared. This leaves us with 3x minus 7. Looking at our last 2 terms, we could factor out a -4. This leaves us with positive 3x minus 7. Now that our 2 groups share a 3x minus 7, we can factor that out. This becomes 3x minus 7 times x squared minus 4. The last thing we need to do is check that we can't factor either of these binomials any further. 3x minus 7 is done, but x squared minus 4, that's a difference of squares. And we know that this difference of squares will factor as x plus 2 times x minus 2. Now this polynomial is factored completely. Looking at this next example, we could actually write this one as the difference of cubes or the difference of squares. I'll write it as the difference of squares. That's x cubed squared minus 27 squared. So with our a as x cubed and our b as 27, this difference of squares will factor as x cubed plus 27 times x cubed minus 27. Now check both of these factors. The first one is the sum of cubes. That's x cubed plus 3 cubed. The second one is the difference of cubes, or x cubed minus 3 cubed. The sum of the two cubes, x cubed and 3 cubed, factors as x plus 3 times x squared minus x times 3, or 3x, plus 3 squared, or 9. The difference of cubes, x cubed minus 3 cubed, factors as x minus 3 times x squared plus x times 3, or 3x, plus 3 squared, or 9. Now this polynomial is factored completely. In example 5, we have a to the 6th plus b to the 6th. We could write this as a cubed squared plus b cubed squared. But the sum of squares is not one of our special binomials, only the difference of squares. So let's instead write this as the sum of cubes. We'll write it as a squared cubed plus b squared cubed. Now this will factor as a squared plus b squared times a squared squared minus a squared times b squared plus b squared squared. Cleaning this up, we have a squared plus b squared times a to the 4th minus a squared times b squared plus b to the 4th. And that polynomial is factored. Let's take a look at one more example. In this last example, when we check for a common factor, we find that each term is divisible by 3 and x. Factoring out a 3x, we end up with 2x squared plus 3x minus 35. Now we have this trinomial that needs to be factored. Let's try the method of trial and error. This will factor into two binomials. With our leading term of 2x squared, we only have one option for our variable terms, 2x and x. With our constant term of negative 35, we do have a couple of options. We could try negative 5 and positive 7, for example. Let's see what x terms this would give us. We have a negative 5x and a positive 14x. That gives us a positive 9x. Let's try it a different way. Let's instead write our negative 7 and our positive 5. This will give us x terms of negative 7x and positive 10x, and those do add to positive 3x. So now we have factored this trinomial. And that will conclude this lecture video on a general strategy for factoring polynomials.